Strong induction and well ordering, section 5.2. Strong induction is very similar to what we did in the last section. We want to prove that Pn is true for all the n in the positive integers, where Pn is a propositional function. And basis step, verify P1, right? Prove that the robot's on the ladder. But this is where it takes a slightly different turn. For strong induction, we don't just need to show assume that we're on the kth rung. We need to assume that we've been on the kth rung, the k minus 1, the k minus 2, the k minus 3, all the way down to the first rung, right? So we're assuming that all of those are true. We're going to use that to prove that k plus 1 will be true. And so we're going to do this primarily through one example. Let's prove that every amount of postage of 6 cents or more can be formed using 3-cent and 4-cent stamps. So one underrated aspect that I get to talk about a little bit here is that we really need to be able to explore, right? If you want to show that this is true, it really helps if you have a feel for it. That is, that you have an idea for why it's got to be true yourself. So let's show that this is true for ourselves first before we sit down to write a proof for it, right? Can we convince ourselves that this is a true statement? So I know I can make 3 and 4 cents. That's not a challenge, nor is it what's being said here. I need to be able to show that I can make everything 6 or more. So can that be done? Well, let's take 3 cents and add 3 cents to it. You get 6. Okay, so I can get to 6 cents. Let's take 4 cents and add 3 cents. That gives me to 7 cents. Doing good there, and I could see that if I add 3 cents to 6 cents, that'll get me to 9, but that means I skipped 8, so let me look around somewhere else. Let me add 4 cents to 3, that gets me to 7, but I've already got that. Well, so what about 4 cents to 8? Okay, so I can start to see that maybe a pattern here is forming. At the very least, I'm starting to convince myself this looks like it could be true. And I just want to emphasize again that this is really handy for any problem. You know, in the last section, we saw one of those divisibility problems. There's nothing wrong with plugging in some ends and testing it out. And this is typically what we call the explore step, right? Get a feel for what it actually looks like. In this case, after messing with this for a long time, what you're going to notice is that the key feature here is that I get 6, 7, and 8. Because after I do that, I can always just add 3 cents to those to get the next 3 and so forth and so on. So they kind of come in these groups of 3. So since we have a 3-cent stamp, once we get 3 in a row, we can create the next 3 postage amounts by adding 3 cents to each. So if I have k plus 1, and k plus 2, I can generate k plus 3, k plus 4, and k plus 5. So let's do this same process using mathematical induction. Let's let P and B the propositional statement function. Postage of n cents can be made using 3-cent and 4-cent stamps. So the basis step's going to be, well, show by hand that 6, 7, and 8 are true. These require a different technique than we're going to be able to do with the inductive step, right? I didn't get to 8 cents in particular, or even 7 cents, using the same technique, right? I didn't get to them by adding 3 cents to something that was 3 cents before it. So I have to show, because they're unique cases, how they can be done. After that, I'm ready for the inductive step. For my inductive hypothesis, because this is strong induction, I'm assuming that Pj will be true for 6 through k, where k is greater than or equal to 8. So picture this as a for loop, right? J is running from 6 to k, saying Pj is true, true, true. So it's stating that everything below k down to 6 cents, we're assuming we can make that postage out of 3 and 4 cent stamps. So how do you make the k plus 1 cent stamp? Well, the inductive hypothesis is telling me, because of that 6 through k statement there, that pk minus 2 will be true. pk minus 2 being true means that we can form k minus 2 cents. I'll take that k minus 2 cents. We don't care how we made it, but we know we can make it. Add a 3-cent stamp to it, and that means we've created k plus 1 cents of postage. Therefore, pk plus 1 is true. Let's see a similar one. Let's say this time we've got 4 and 7-cent stamps, and the statement is we can make more 18 cents or more. In this case, I'm going to leave it to you, but I do encourage that you do it. Get out and explore this. What does this look like? And what you'll see is that the lower bound here, what's keeping us from being able to go further, is in fact the 4 cents part. So what we need for our basis step is to actually show 4 different steps this time. P18, 19, 20, and 21 have to be shown kind of manually here that they can be made using the 4-cent and 7-cent stamps. The inductive step then is going to look very similar. We're assuming that this Pj is true for 18 through k, where k is greater than or equal to 21, right? Because we've shown that 21 through 18 will be true. So we want to show that pk plus 1 holds true. The inductive hypothesis provides for us that pk minus 3 is true. This is the statement that we can form k minus 3 cents of stamps, add that 4-cent stamp, and we can show that we get to k plus 1 cents of postage. Therefore, pk plus 1 is true.